So this will be a fairly short video in which I'm going to introduce the concept of parse trees. Now these will be very important for you if you use context-free grammars and other more complicated grammars in the future for actual applications. So in particular, if you ever end up designing a compiler, the concept of a parse tree will be very important for you. There are also representations of the derivation of a string using a grammar that are really easy to visually understand. So all you need to remember for this is what a context-free grammar is and the concept of a tree. That is something that looks like this as a graph structure. So before I show you what the parse tree is itself, I'm going to show you one of the other ways in which we represent derivations, and then you'll see the advantage. So let's imagine that we have this grammar here with non-terminals STUV and terminals 0, 1, 2, 3, so all the strings are made up of 0s, 1s, 2s and 3s, with the rule set over here and the usual start non-terminal S. And imagine that we want to see how we can generate this string here. So the first line that's popped up just now shows one possible derivation. So from the S, we expand using rule 1 over here to TUV. Then we expand the T using the first of its two rules into 0T1. Then we expand the T into an epsilon, so it disappears, and we end up with this string. Then we expand the U into the only rule that it can expand into, which is two 2s. And then finally we expand the V to replace it with a 3, and we end up with the string W. So that is one way in which we can apply the rules in a particular order to generate the string that we want. Now what you'll see is that I've also listed two other derivations, both of which are valid and generate the same string. And there are many other. So what I would suggest you do at this point is pause the video and then follow through those two derivations and see if you understand them, and then try to think of another derivation that you can. And then when you're done, we'll move on and explain what a parse tree is. So at this point you can probably see that the derivations that we just showed then have one problem in that there's a lot of ways to write down a derivation even if they all end up expanding the rules in the exact same way, just based on which rule we expanded each time. And the other problem too is that it's not particularly nice. We can't always see what's going on at every point in time. The good news is that there's a better option, and that's the parse tree. What we use for the parse tree is quite simple. We have the root of the tree being the start non-terminal, and then nodes become child nodes of another node whenever we expand using a rule from that particular parent to those particular children. So for example, when I expand the start non-terminal to T, U and V, I write that like this. So the children of this node S are the parts of the right-hand side of the rule that I expanded it with. So then if I continue on, I can expand the T into 0T1. The U can only expand into 2, 2, and the V can only expand into the 3. And finally the T expands down into epsilon. The resulting string of a parse tree is simply the leaf nodes of the tree read from left to right. So it's important to note that left and right have important meanings in the parse tree. So when you write things down, it's not just that T, U and V are the child or daughter nodes of S, but they're those child nodes in order. So we can't, for instance, just go willy-nilly and put, oh yeah, there's a U, there's a T and there's a V, because that doesn't give us the string that we want at the end. And remember that order is important when it comes to the strings. So you know that given a grammar, we can generate a parse tree to show the way in which that grammar generates the string. So one other important concept is the capacity for a grammar to generate things, and we call those the generative capacities. So we say that a grammar has a weak generative capacity, and that is the set of strings that it can generate. Or, more put better, it's the language generated by the grammar. That is its weak generative capacity. We also say that it has a strong generative capacity, and that is the set of parse trees that it can generate. Now, in the case of the example that we showed before, there was only that one possible parse tree for that string. You'll learn later through the lectures that in some cases we can have particular grammars in which certain strings can have multiple parse trees that we can have which result in the same string, and we call those ambiguous grammars. And we'll even find that there are some languages where there is no way that we can build a grammar that doesn't have some strings for which it has that ambiguity, i.e. the ability to build two different parse trees for the same string. So this strong and weak generative capacity are actually different things. Now you'll note that right at the start of this video I was talking about derivations. So for any parse tree there are multiple derivations, but we don't talk about a generative capacity in this course in terms of the derivations that we can build, because we can always build multiple derivations for the same way of expanding things just by deciding to expand one before another. That said, when you go to apply grammars later, particularly in compiler design as I mentioned before, you may end up in a case where the order in which you expand things can be important. But for this course we won't talk too much about that. So, hopefully that was short and sweet. What you should know at this point is what a parse tree is, at least just the bare basics. You'll get taught a lot more when you go into the lecture. And you should also have an idea of what I mean when I use the words strong and weak generative capacity. If you want some more information on this, you can see section 11.6 in the textbook.